All right, here in section 3.5, we're going to look at a topic that is specific to business. It's called marginal analysis. The foundation for marginal analysis was presented in section 3.4, where we learned about the differential. Keep that in mind because I'll probably make reference to what we learned in section 3.4 as we go through this section. The section objectives we're going to look at here in section 3.5, we're going to look at objective 1, where we determine a marginal cost function, and objective 2, where we determine a marginal profit function. So marginal analysis is nothing more than the study of change in the dependent variable that results from a single unit change in the independent variable. A unit change, that just means the change of a single unit. So here's our definition we're starting off with. The marginal cost function, which can be given as MC of x, it's nothing more than the derivative of a cost function. So marginal cost is the derivative of cost. What marginal cost does is it gives the approximate cost of producing one additional unit when you're at production level X. So if you're at a production level of, say 500, marginal cost will give an approximation of the cost if you were to produce the 501st unit. And like I said, this is basically, the differential concept that we learned in section 3.4. So there's a graph, the blue curve you see here, that's some generic cost function. So we see, on the x-axis, you go from x to x plus 1. That's a delta x value of 1. And then we see on the corresponding y-axis, c of x compared to c of x plus 1, that the difference there is the actual change in cost. We also saw in section 3.4 that if delta x, which equals dx, is small, no more than 1, then the differential did a good job of approximating the actual change in the y-coordinates. So, this figure over here to the right is showing exactly what we saw in section 3.4, but now it's applied to a cost function, and that differential in y that we learned in section 3.4, dy, well, that is now, because we're dealing with the cost function, it's marginal cost. So the best thing we could do right now is just kind of jump into an example. Please write all this down. The cost of producing X upright pianos is modeled by that cost function. X represents the number of pianos produced, and C of X is the cost in dollars. So we're gonna head off to the chalkboard. The first thing I'm gonna do is determine the marginal cost function, which isn't bad, it's just the derivative of the cost function. And then we're going to find and interpret marginal cost at 20. So let's head off to the chalkboard and work through this one. All right, hey, our first example here in the study of marginal analysis, you were given a cost function for the cost of producing X upright pianos. That's the cost function. X is the number of pianos. C of X is the cost in dollars. So we were asked to compute the marginal cost function, MC of X, and also find and interpret MC of 20. So first things first, marginal cost is nothing more than the derivative of the cost function. So the marginal cost function, to get the derivative here, see, that's a 43x plus 50. So there's the marginal cost function. It's just simply the derivative of cost. So next we're supposed to evaluate and interpret MC of 20. Well, we put 20 in for the X. And we do 43 times 20 plus 50. My calculator gives me 910. So what does this mean? Well, in the marginal business function world, this means that when we're currently producing 20 upright pianos, well, let me write that down. At a production level of 20 upright pianos, the cost to make the next upright piano, it's the next unit. Well, the next one would be the 21st. So the cost to make the 21st piano is, and this is kind of an important word to get in here, about, because marginal cost gives a very good approximation to the actual cost. So the cost to make the 21st piano, it is about $910. So remember, in the marginal world, it's giving an approximation for the next item. So let's head back to the slides. Well, you know what? Before we head back to the slides, I want you to practice the marginal cost concept. So section 3.5 exercises, I'd like you to right now try number 22. So pause the video, do number 22, restart the video, and I'll be here to work through it. All right, number 22, the accounting division of Cranky Crank Company had determined its weekly cost of producing its continuous variable transmissions, CVTs, can be modeled by that cost function. X is the number of CVTs produced, and C of X is the cost in dollars. So here we're asked to evaluate and interpret MC of 210. I know that there was also the directions in there of first find the marginal cost function. Well, folks, we can't do MC of 210 unless we first get the marginal cost function. So the marginal cost function, remember, marginal cost is just the derivative of the cost function. So when I differentiate the cost function, I get 600 minus 2.5x. So MC of 210, well, I put 210 in for the x, and when I do that on my calculator, I end up getting a friendly number, 75. So now the interpretation. So when our production level is at 210 CVTs, so at a production level of 210 CVTs, the cost to make the next CVT, well, the next one would be the 211th CVT. That cost is about $75. That's it. Hopefully you got it, folks. So let's head on back to the slides and talk about the other marginal business functions. All right, hopefully, marginal cost is making sense. And, if you've taken an econ class, you may have dealt with the marginal business functions, or at least heard of the marginal business functions. Besides marginal cost, there will also be a marginal revenue and a marginal profit function. So the marginal revenue function, it can be represented as MR of X. It's nothing more than the derivative of revenue. And it's the approximate loss or gain in revenue by producing one additional unit when you're at production level X. Marginal profit is defined similarly. So now out there in the so-called real world, the two big marginal business functions are marginal cost and marginal profit. You know, I did list marginal revenue here for completeness sake, but by and large, you're going to be most interested in the marginal cost or marginal profit. So let's look at an example here. We're going to practice, you know, the marginal profit function. So here's another example to write down, get in your notes. A lot of words, but we're going to do two things in this example for this profit model for the number of bobbleheads that are produced and sold. In part A, we're going to determine marginal profit, the marginal profit function. Once we determine marginal profit, we're going to evaluate it at 3,000 and we're going to interpret. And then part B, we're going to evaluate marginal profit at 5,000 and interpret. And then there's, you know, a couple of other items I'm going to show you, you know, when we get to the board about this situation. So let's head off to the board and work through this example. Okay, folks, this example, a lot of words. I asked you to write them down. I didn't write them on the board. I just wrote down what the profit function was. Part A, we're asked to get the marginal profit function, MP, and evaluate the marginal profit at 3,000 and interpret. And then in part B, the marginal profit of 5,000 and interpret. So let's start off part A, the marginal profit function. It's nothing more than the derivative of the profit function. So here's the profit function. We get its derivative. That's negative 0.002x plus 8. Now we evaluate this at 3,000. And when I put 3,000 in for x, let's see, I end up getting 2. So what does that mean? Well, that means when we're at a production level, what are we making here? Bobbleheads. So when we're at a production level of 3,000, to make and sell the next bobblehead, so that would be the 3,001st. To make and sell the 3,001st bobblehead yields an additional profit of about $2. So let me say it again. At a production level of 3,000 bobbleheads, to make and sell the 3,001st bobblehead brings in an additional profit of about $2. Part B, evaluate and interpret MP of 5,000. Well, here's the marginal profit, so I put 5,000 in. Ooh, I get negative 2. Now, what in the world does that mean? Well, it means at a current production level of 5,000 bobbleheads, to make and produce the 5,001st bobblehead, the next one, the 5,001st, would result in about a $2 loss in profit. You wouldn't want to make that 5,001st because you're losing some profit. So now, I want to point out graphically what this really means. So I'm not going to draw an exact graph here, but if you were to graph the profit function, I mean, it's a parabola with a negative leading coefficient, so it's a sad parabola. It's looking something like this. That's what the profit function looks like. Clearly, right here, that's where profit is maximized. So let me just kind of arbitrarily say right here, that was 3,000, and here's 5,000. Notice that both 3,000 bobbleheads being made and 5,000 bobbleheads being made and sold you have a profit on both of them. It's just that over here, well, the tangent line has a positive slope. Marginal profit is positive, which means if you increase production by 1, you're going to get a little bit more profit. Whereas over here, if you increase production by 1, you have a little less profit. So I always kind of thought of the profit curve. I mean, this is where you want to get to. You want to get to maximum profit. You want to maximize profit. To the left of where maximum profit is, over here, marginal profit will be greater than 0. To the right, marginal profit is less than 0. And here's how I always interpret it, is if I work for this Tesh company and the boss person says to me, you know, hey, we're currently making 3,000 bobbleheads. Should we increase production? Well, if I know marginal profit is a positive number, I'm going to say, yep, increase production. But if we're making 5,000 and boss person says to me, should we increase production? Because MP of 5,000 was negative, I'm not going to say yes, increase production. In fact, I'm going to say no, don't increase production. You want to decrease production. This is what you want to get to. And I'm just going to foreshadow what's coming up in a future chapter. That point right there is when, well, it's when marginal profit is equal to 0. But that's just a little foreshadowing. So, to make sure you have this kind of dialed in, you know, marginal profit and how to interpret marginal profit. In section 3.5, I'd like you now to try number 27. Pause the video, do number 27. When you're done, restart the video, and we'll see if you have it correct. Hey folks, number 27, here was the, you know, there were words here, I'm not going to write them down. Here was the profit function that you were given. X is the number of radios produced and sold. P of X is the profit in dollars. So part A, we're supposed to find the marginal profit function, evaluate marginal profit at 700, and interpret. So here we go, part A. Marginal profit, nothing more than the derivative of the profit function. So that's a negative 0.02x plus 12. Evaluate the marginal profit at 700. And when I do that, see, and I use my calculator, what do I get here? I get negative 2. So what does this mean? I'm going to interpret it. I'm not going to write this down. You know, I'll say it slowly. It means at a production level of 700 radios, to make and sell the 701st radio results in a loss in profit of about $2. It's a negative number. So one more time. At a production level of 700 radios, to make and sell the 701st radio results in a loss in profit of about $2. So then in part B you were asked, you know, if the corporation is producing and selling 700 radios per week, is profit increasing or decreasing? Folks, marginal profit, we just saw it was a negative number. That means it is decreasing. The profit is decreasing. You're on the wrong side of the profit curve. You're on the side of the profit curve where marginal profit is negative. You don't want to increase production. You want to decrease production to try to get closer to maximum profit. That was it for number 27. Let's head back to the slides and see how we're going to finish off this section. All right. I hope you paid particular attention to, you know, the marginal profit when we have the graph I put up on the board, you know, when when we're maximized at profit, what the marginal profit value is, when marginal profit's greater than 0, or when marginal profit is less than 0, which side of the profit curve we're on. Because knowing if marginal profit is greater than 0 or less than 0, you would know if you should increase production. Everything that I just mentioned in the last example. So our final example in this section is one that requires a little bit of algebraic work. So again, write all this down. Here we're given the price demand function for a company that makes a pen. The price demand function is given by P of X equals 250X plus 748 all over X plus 30. X is the number of pens demanded, and P of X is the unit price of the pen in dollars. We are given that the cost for X 100 pens is given by, well, there's the cost function. C of X equals 30X plus 105. So what we're going to do is we're going to determine in part A the profit function and the marginal profit function. So we're going to have a little bit of work to do in coming up with the profit function. And then once we have the profit function, we know the derivative of the profit function is the marginal profit function. And then in part B, we're going to compute the marginal profit at 5, and we're going to interpret that. So let's head off to the board and work through this example. All right, this example, there were a lot of words, and I need to make one change, in the slide. I think in the slide it said the cost for X 100 pens is given by that cost function. X is just the number of pens. It's just the number of pens. I had a typo. I have the word 100 in there. So delete that word 100. It's just pens. So part A, we're supposed to get the profit and marginal profit functions. And then part B, compute MP of 5 and interpret. So we can't get the marginal profit function until we get the profit function. Now you need to remember profit is equal to revenue minus cost. We don't even know the revenue function here. All we have is the price demand function. This is the price demand function. It's telling us the price at a demand level of X. Well, remember revenue as a function of X. Well, remember revenue is just price times quantity. That's it. Well, here's price. It's an ugly looking expression. That's price. The quantity is X. So the revenue function is X times 250X plus 748 over X plus 30. That's the revenue function. So the profit function is revenue minus cost. So here, this is revenue. And you know what? When I write it down here, I'm going to distribute that X to get a 250 X squared plus a 748X over X plus 30. So that's revenue minus cost. Well, cost is 30X plus 105. I should put that in parentheses, minus the quantity 30X plus 105. So I've mentally put it in parentheses. Now I'm going to distribute the negative to get negative 30X minus 105. Now there are some people that would say, hey, let's get a common denominator and get one expression over here. I'm not one of those people. I think this is fine as a profit function. So let's get the marginal profit function. So here's profit. So marginal profit. Remember, it's just the derivative of the profit function. And we need to use the quotient rule here to get started. So when we differentiate this term, we need the quotient rule. So the quotient rule says the derivative of the numerator that's derivative of the numerator, times the denominator, minus the numerator, times the derivative of the denominator. Oh, well, the derivative of the denominator is just 1. All over the denominator squared. Okay, so we've differentiated this piece of the profit function. We got to finish off the derivative. Well, that's not too bad. It's just a minus 30. I don't want to simplify that, but that is the marginal profit function. So I'm not going to bother simplifying it because in part B I can toss 5 in for the x's in the unsimplified version, no problem. I don't need it simplified to evaluate it. So when I toss 5 in for the x's, and I use my calculator, believe me, I get 55.75. So what does that mean? Well, that means when we're at a production level of 5 of these pens, whatever these special pens are, when we're at a production level of 5 pens, you know, the additional profit on making and selling the 6th pen is about $55.75. So these are probably the most difficult problems we could do right now, where you're not given the profit function. You have to construct the profit function yourself. Just remember, profit is revenue minus cost, and remember, revenue is price times quantity. But that's it for this example, and that's it for section 3.5. So you can now do all the exercises that are assigned in section 3.5. Thanks for watching.